Hello! Oh, that's probably loud. Hi, hello. That's going into the red. There you go. Okay. Look, I knew I was muted. I knew I was muted. There was a conversation going on behind me, so I was waiting for it to finish to unmute. Okay. Um, so, am I loud, by the way? I don't know if I'm loud. When I'm looking at the thing, it's going into the red sometimes, so I don't know if that's too much. But, I can explain a cost function. So, okay, say you have an AI, a brain. Actually, hold on. This is gonna look a little. Hold on, MS Paint, MS Paint. I don't have the scene properly set up yet, so it's gonna look a little goofy. But let's see if I can. Will this work? Do you need to be on top? Yes, you do. Okay. Uh. Um. Oh, that's because it's a game thing. I think I did that wrong. No, I didn't. What's your dealio? Oh, right, you're also behind the... Yeah, there you go. And then you should be there? Yes, okay. Give me just a second. I also need to show chat. I'm just gonna... I'm so glad that you can just copy-paste things from one scene to another. Boom. And, or you know, I don't want to put you there. I want to put you, like, there. Okay, and then put you behind me. No, behind me, friend. There you go. Alright. There we go. And boom. Boom. What if I do this? Oh, why do I have to press transition for that? Okay, what's it called? I forgot to add a microphone to the scene, so that's why I was muted. But it's fine because you weren't here. So, so you have neural network, right? It has the input layer, the internal layer, and the output layer. The internal layer just generates a number based on the input layers when they're multiplied by the numbers that these lines represent. That's not the important part. The important part is the cost function tells the output layers what it wants it to do. Like, say, it wants this bottom one to go up and this top one to go down. So then the brain does a thing called backpropagation, where it changes all of these lines, like the values of all of these lines, by a small amount to move it closer to what the cost function wants. So in this case, telling this to go down means that the value of this line, which is green because it's positive, is going to go down. So it's going to become slightly redder from a visual perspective. And this line, and this one that's supposed to go up a little, this one will become slightly greener because it'll go up. And I think that, is that right? I think that's right. I think that's how that works. It'll go through each of these and nudge them in a way that makes these go up or down. If anything, it's like, it'll be like, this goes down, so it wants all of you. What am I thinking, brain? Right, if this needs to go down, because it has a positive relationship with this needs to also go down. And for this to go down, then this weight has to go down from this input or whatever. And so it'll just go through it and do whatever it needs to do to make these go down. That's all the cost function does. It tells what it wants to change in the output, and then backpropagation will go through and do what it needs to do to make that change. That's the best I could explain it, bro. I don't remember. It's been a while. But either way, hold on. Button. Boom. Look, I prepared, bro. I did stuff before stream. I am prepared. Correct. Because it can't change the inputs themselves, because that's kind of like, if you think of it as brain, the input is all the sensory information you get. You can't change that. I can't change the color of a wall in order to make me be better at guessing the color of the wall. Instead, it changes the stuff behind the inputs so that my guess is closer to the actual color of the wall. Is the best I can do. Dude, I know, I'm sick. Okay, so basically, the plan for this is just, I guess it's better to start down here. This is the plan. We have an AI that would predict a simulated foreign exchange market. For the sake of not having any government anything involved, the currencies, instead of being real world currencies, is just electrons and positrons, because that's cool and themed. And I'm thinking the AI would start with 500 electrons and 500 positrons, and by exchanging them for each other based on the value each one has, it is trying to make a profit. So, like, it has 500 electrons, 500 positrons. Say, based on everything that the market has done so far, it thinks the value of electrons is going to go up, so it converts some of its positrons into electrons, so that now what am I thinking? If the value of electrons goes up, then no, since the value of the electrons goes up, it wants to convert its electrons into positrons, because they'll turn into more positrons, because say it's like 1-to-1 at first, right? So 1 electron is 1 positron. If that increases to 1 electron is worth 2 positrons, then if I exchange 100 electrons, that would turn into 200 positrons. And then when that value goes back down, I can exchange those 200 back to be, now I have 200 electrons, where I previously had 100. And that's the plan. It wants to have as much as it can by exchanging them at the right time. Yes, exactly. It wants all of the trons to be as high as possible. And to avoid having to make a cost function, instead of doing whatever the heck I just explained, it would be a genetic algorithm, meaning that I don't have to do any kind of math. It's just the ones that got the highest score get to create clones of themselves. The word is reproduce, but I don't think that's really, like, that doesn't really apply here. I mean, I guess you could say the broke ones die and make it an evolution thing, but the top performers, the ones that make the most profit, get to go on, like, the next generation is based off of those guys, and there's going to be mutation so that there can actually be improvement. And then I'm thinking, to get closer to the actual behavior of the foreign exchange market, after some amount of generations, the top AIs of the past generation would be included in the simulated market to represent knowledgeable traders, right? Because in the foreign exchange market, you have the majority of people that don't really know what they're doing, so you can simulate their actions by just adding up a bunch of randomness. What am I thinking? Yeah, you can simulate most people by just adding up a bunch of randomness, but that takes away the input of the valuable things. It also can't really have any, like, political or, like, political influence, because it's like, you know, value of currencies are affected by the actions of world, like, news and whatnot. We can't do that because there's no world news in this, so it's not going to be exactly accurate, but I think we can get more accurate by having more influential inputs, I guess. So, yeah. So, the plan for the initial simulated market is just random traders that are adding a random number between -1 and +1. And the more traders you have, the more activity it is. I could show you, like, how that works. I remember I saw this video a long time ago, or not a long time ago, like a few months ago, that was, oh my god, I have hiccups, but they're not hiccuping. It was basically saying that because most of the people in a foreign exchange market don't know what they're doing, you can simulate them by just having a bunch of random numbers being added up over time. So that's what the plan is here, is to just have that simulated by the sum of a bunch of random numbers. Then we'd have the past AI iterations, so that means the past AI are being included, though they're not part of the group that is reproducing. They're just in there to affect the movement of the market. And then for the display, it'd be Candle and Wick. And also be for the AI, which Candle and Wick... Guys, we're going back to the whiteboard already. Okay, Candle and Wick. Look. Get out of here, Stinko. Bye-bye. Okay. Candle and Wick is basically just you have a box, and then from that box you have lines. This all represents stuff. You have text. You have the opening value. So, okay, I should clarify. This box represents an amount of time, right? Like, from this end to this end is, say, an hour, right? So let's make this guy green. Oh, that's not the right... There you go. By making this green, it means that this value increased, okay? If it was red, it would mean it decreased. And I think that's kind of it. If it stayed the same, I guess it would just be black, but then it would be... I don't know. It'd probably just be very, very thin in some color, because I don't think it would be able to be exactly the same value over the time unless nothing happened. I don't know. The point is, that's the thing. If this is increasing, that means that this bottom right corner is the opening value. So, like, when this hour started, this corner represents the value that it initially was. And then this one, the top right corner, is the closing value. So, at the end of the hour, this was the value of the... What? The value of the currency. these wicks, this line, which I guess is 2 lines because technically this will be filled in. Like if I do this, there you go. These lines represent the highest and lowest points during this hour. So like, oh no, please. Hi, there you go. So this is the highest value during the hour, and down here is the lowest value during the hour. Or I would just call that low. And then if you had it be, hold on, if you had this all but red, I can do this, then this stuff would be the same. I'm not gonna change colors of those because that's gonna be weird. But this value would be the same, but this one would be the opening value. Here you go. This one would be the closing value because it decreased. So the opening one is the higher one. That's all that changes with the colors. Is like, but for the AI, it doesn't really need to make it doesn't need to differentiate between those because it gets the opening value, the closing value, the highest value, and the lowest value. And I'm thinking that this would be one piece of input for the AI. So if we go back here, then, so that will be the style of it. The input, it gets the open, close, high, and low of some amount of candles, right? Because these are 4 different values, so that means a single candle is 4 input neurons, because it's 4 numbers that's affecting the whole output process. And then the X amount of candles, I think would be able to change. Like the number of candles that it looks at would change via mutation, right? Because we can give it a starting value. I don't know what we would do, like what am I thinking? I don't know what number we should start off with in terms of how many they're looking at. But through mutation, they can gain or lose input neurons. So they can like, I'm thinking if you add one, it'll just add one instead of giving you a specific one to look at. So say you have 10, so you're looking at 10 candles. If you mutate to add another one, that's going to look at the 11th candle automatically. But when you lose one, it could be any of them. I don't know. That'll figure itself out. Whatever. But either way, back to this. The output, oh yeah, and also as an input, it would get the number of electrons it owns and the number of positrons it owns. This allows it to keep track of like how much money it has. And that matters because in its output is going to decide like how much of its money to put in, like to convert. So it'll be able to place, which is a threshold. Since this is pretty much always going to have some value, it's only going to do something if that value is over a certain, value, I guess. Which threshold, over a certain threshold. So if we set that threshold to like 0.7, then if the value of this output is over 0.7, then it's going to place based on these other two. Which is, it's either going to be a sell or buy, which is just telling it, sell would be exchanging positrons to electrons, and buy would be converting electrons into positrons. And then the exchange amount is going to be a percent, which is just the percent of all of the things it has. So if it has the 500, 20%, I think, would be 100 electrons. Or positrons. But yes, okay, and then finally, there's the genetics, which the reproduction, I'm thinking top 3 reproduce. I don't know if 3 is the best number. I don't know what the best number would be, but for now, I put 3. And then what percent of the thing they represent would probably be based on their performance. So say number 1 made a profit of 100 electrons, number 2 made a profit of 70, and number 3 made a profit of 50. That adds up to 220? Yes, 220. So number 1 would be 100 out of 220, which is, I think like 55%? Maybe? Probably somewhere around there. But 55% of the new ones would be copies of number 1, and so on for each one based on its final balance and the total balance that was by the top 3. Okay, and then input, I already told you they can add or delete, what do you call it? Input, so looking at different candles. Connections, which is the lines that were between the circles before. They can add connections, delete connections, or nudge the value of connections. So say that middle layer where it just had 1, if there were 5, it could add a connection to the 5th one or the 3rd one or any one of them. Or it could delete a connection that it already has, and then otherwise it could change the value of any of the what do you call it, connections. Then node, it can add, delete, or change the bias of nodes. The nodes are the circles in those internal layers, so that would be what it's making the connections to. So it can either add another one, delete an existing one, or nudge the bias of one, which the bias is basically just a number that the node will always add to the weighted sum of all the inputs. So if adding it all up, it got a 5, it would add its bias, which was like 1 or something, so for a total value of 6. So you can change the value of that, is what I'm thinking. Water. Okay. This was me testing like how to do the different AIs, because obviously if we have multiple guys going at once, we need to be able to keep track of them, and ideally we don't have like individual, what do you call it? I don't even know what to call it. I don't have to manually create each of the agents, which I don't even think I'd be able to do because I want mutation. So I'm thinking we do with classes, which I don't even know how to explain what a class is. It's basically just a category, I suppose. If you think of it class as in video game terms, then I created this fake class, which is agent, and this is what is run as soon as the agent is created. So when I created this agent, A1, I gave it an input of 0, which is this value, named value, and it ran this function, which set its internal variable called value to the number that I gave it. And then I ran this, which is a function, this function, sorry, so that all classes can run this function automatically, and it does this based on their internal variables. So I'm thinking we can have some kind of loop that will create all the different AI, so we can change the number of AIs that we want in each generation if we want to. What am I thinking? I forgot what I was saying. Right, we have a loop that creates all of them. So that would allow us to have the creation and reproduction automated. So all we have to do is sit there and watch it go. I think that's all. I think that's all the prerequisite gobbledygook that I had to say. So today, I don't know what to do today. I mean, I guess we just... Okay, today we'll probably be doing how we want this to be set up. We know for a fact... Okay, what all do we know for a fact that we are going to need? Needs. Wrong one. There you go. We know we will need a list with all of the previous candles. It's probably not going to be all of them, but like up to a certain number. That's going to be what they're taking their inputs from. And this could possibly be multiple lists. And it could also be a dictionary. Because if we do it like a dictionary, then that means that I can call example equals... I don't remember exactly how lists work. Let's see if I can figure this out. Let's say test colon list. No? Test equals. If we do dictionaries, that'll be next time. I don't know, it doesn't matter. I'll figure it out. I'll remember. Point is, we could do a dictionary, because a dictionary could allow us to have multiple values associated with one thing. Then, what else? So we have the list of previous candles. We would need a function. I think it'd probably be best to have a function that that I don't know what you call it. Okay, that weighted sums previous, I guess, previous layer? Yeah, layer. And then you have what do you call it? A loop, I guess. Or not a loop. For loop, yeah. For loop that does some function for each node. There you go. Okay. What else do we need? What else do we need? What else do we need? We need a function that copies information of top performers, and probably a function that modifies the brains of new agents. With this, is that everything? They have their inputs. Oh, we need the, obviously, we need the functions that process and produce outputs of agents. Also, of course, we need the simulated market. I'm thinking, I think the simulated market should be, what do you call it? I think the simulated market should be personal to each agent. For the sake of, like, ultimately, it's kind of like the motion of the market on an individual turn is more or less random. So by having each agent have its own version of the market, it kind of emphasizes the nature of that randomness, so that any strategy that they produce is actually a strategy that would work outside of the turn that they were in. Because obviously, if we had one market that they were all acting on, then they would be affected by the other people's actions. And I don't know if it's possible, but I would rather not have any of them be. Actually, yeah, it'd be better to have them isolated because otherwise they could ride on each other's coattails or screw over other guys, which would be not cool for the sake of producing a better AI. I don't believe. Maybe it would. I don't think so. So I think simulated market that is personal to each agent, which means that we would need a function in the class that generates I guess market movements. From a commentary note, I guess this could probably be, what do you call it? I guess it would be create X number of candles, generate output, create next candle, and then repeat steps 2 and 3. So it would produce a number of starting candles, and then from there it would create an output, and then do the next candle, and that would just go on for some amount of time. Repeat steps 2 and 3 for some time. That time would be constant, and the number of candles it creates at the beginning would also be constant. Say like 20, right? It would create 20 candles, and then, what do you call it? What am I thinking? Yeah, it would create 20 candles, then the AI would be like, okay, based on what I can see of these 20 candles, I will choose this output, which may just be nothing, and then it creates the next candle, and that will continue for however much time, or I guess however many turns, to see, like, because that would be the same. I guess it depends on if they all run at the same speed. I assume they would. Actually, it would just have to be turns, because I don't know how to do time. I don't know how to look at real time, a timer that is independent of gobbledygook. Not my thing. But yes. Okay. Then, what else? With this, what happens? You generate all the candles. This guy can see all the candles, or it can consult this list to see the candles, which means that this would also need to be personal to the thing, because that'll be random. All of this is going to be personal because that's within the brain. Then simulated market. I think that's it. Yes, I think that's it. So in terms of AI functions, or AI, I guess AI. What am I thinking? I forgot what I was gonna say. I was thinking of something and then I forgot it. You have AI something. The AI itself needs to keep up with previous candles and the amount of currency that it has, right? So that means that, okay, variables. There you go. AI variables. So this is what variables is it going to have? For one, electrons, protons, list of candles. I think that's actually it. It's the variables that it's gonna have is the, I guess it would be list of weights. Would that be a list of weights? Okay, did you have each node? I guess each node would be a list of weights. So then it would have a list of nodes, which are themselves lists of weights. Yes. And I guess this is more so just the layers that are lists. So I'm gonna label this layers. List of candles. Actually, yeah, all of this is just layer information. It's just gonna be this is all input information. This is the internal things, and then the output, which means it's gonna need a. I'll just copy this over, really. There you go. Boom. And then we can also get rid of these dots. Yes. Place. I can get rid of these. Sell by. And exchange amount. And I think that's all that this is all that it needs. Which means this is the stuff that we need to clarify when it is initialized, which is this guy right here, this function. That's what init stands for, initialize or something like that. Like we have it set its value when it's initialized. In the beginning, we need to set these variables, which I'm pretty sure the only ones that we care to input are going to be the electrons and protons, because all of this is determined by either the neural network or the simulated market, which we don't have control over. I think this is everything that we are going to need, which means the only thing I can think to do now is start. So, I'm going to, I guess we just modify this. Do I want to call it agent? I will call it agent because agent is cool, but know that I'm whatever. Okay, so electrons, positrons, electrons, positrons. Oh, we also, for the sake of calculating how much profit they make, we should have I guess an exchange rate like variable, which is just going to be the value of it's going to be the closing value of the last item in the list of candles. But I think it's easier to just have that also stored as a variable that we can easily reference. So electron to, I keep forgetting that's, wait, what are you talking about? Oh, okay. Dude, I'm trying to, what? How did I get here? Where am I? Minus to plus exchange rate, and then plus to minus. There you go. And that's just for calculating how much it converts to whenever they exchange. Which means that I guess we do need inside of this. This would be function that converts currencies. Did I spell that right? Yes, I did. Okay, so you have electrons and positrons. We have electrons and positrons. Okay, and then that's all that we need for input. So it'll be self.electrons equals, I guess, just electrons, high. And then same thing with positrons. Positrons equals positrons. Boom. Okay. Now everything else is just going to be a starting value. What do I want to be the starting values of this? Friend, I would appreciate if you didn't do that. Okay. I guess we can put these in these. Oh, okay. I'm doing things I don't know what. There you go. Okay, electrons, and then positrons, we will move to... Oh, that says protons. That's supposed to be positrons. That one. There you go. Then, the exchange rate. I guess in terms of initializing, we'll just set these to 0. Self dot. Now, how do I want to... I'm just going to call it E to P, which is ETP. ETP equals 0, or we'll set it to 1 by default. And then, same, PTE, boom, is 1. List of candles, self.candles, is equal to just an empty list. List of nodes, which are themselves lists of weights, which is nodes, or self.nodes. Self.nodes equals empty list. Okay, then place self dot, I guess place. Can I put a question mark in there? I cannot. Then I should just be fine with place. We'll set that to 0 by default. Sell by. I feel like there's a number that would represent selling or buying, but I don't know what that is. I guess for now we'll just call it SB. And then exchange amount is... It's gonna be EXP, but that stands for exchange percent. I guess if anything we can do EXPT? Or what's usually the abbreviation percent for percent other than the percent sign? I think that'll be fine. Yes, and then we can get rid of that. Boom. So, this is our stuff. This is all the stuff that we need to stuff. Okay. I mean, I guess this is all straightforward so far. We can create the functions for... Huh. Should we have these... No. We don't want any... Yeah, we want these to be just default values so that they can easily be overridden for the sake of when we reproduce. When we reproduce the agents that are there, we want to be able to easily set their values to the values that they used to be in the old agents, so that we can... Yeah. Okay. So then, what else do we want? I guess we can do input, which is collecting all the input information, which technically... I mean, okay. Yeah, this is fine. So, should we have a list of inputs for the sake of just turning them all into numbers? Because they're all going to be numbers between -1 and 0. Or is it 0 and 1? I think it's numbers between 0 and 1. The weights are between 1 and -1. Yeah. So, I guess we should have a list of inputs. So just self dot inputs is an empty list, then it would be for length of, or is that for, for, I guess I in length of nodes, which actually, I mean, sure, or self.nodes. Yeah, for I in self.nodes, you will do whatever you do. For that though, I want to, what would I do? It would be self.input, so, is self.input a thing? No, that was just, okay. Self.inputs dot, okay. I guess we can clear it. Technically, would we ever need to? I'm gonna have it clear. Sure, dude. Self.inputs.clear and then self.inputs.append with self.electrons. Then the same thing with positrons. So the first two values, value 0 and 1, are going to be electrons and positrons. That way we can have this loop that will be all of the nodes. Self.nodes. I guess the way that I'm setting this up right now would mean that unless inside of the nodes we had something to identify what item it's supposed to be looking at, which we could do, but I don't really see that as necessary. So we can kind of just leave that as is and have this be, that means that when you add or delete a node, wait, no, it wouldn't be node. It'd be candles. Yes, not nodes, candles. When you add or delete a candle, like that you're looking at, you're just extending or retracting the amount of information you have. Which makes me wonder, what would be the downside to just having that maxed out? Would there be one? I know that for a person there would be one, because that's more information for you to think about, and you want to make it as simple as possible for you. But given that the AI is more so looking for success rather than simplicity, maybe, I don't know. But it'll do whatever it does. So, for you, for I in self candles, I guess it'll just be self.inputs.append. Oh, inputs.append with self.candles. Okay, self.candles. I want this to be a range from 0 to the length of self.candles. There you go. Okay. Does that need to be -1? I don't think it does. I think it's fine. Okay. So that'll go through all of the candles and add the value to... Except that's not how that works. Right. Okay. Because that has the open, close, high, and low, which means we can either have a separate list for each of those, or we have a dictionary with those in it. I could technically Google what a dictionary looks like and use that. Give me a second. Give me 1 second, and I will look up on my phone what a dictionary looks like in Python. Python dictionary. Boom. It is... Okay. So you have the curly brackets, then it's got strings. Which, do they have to be strings? I would kind of hope. I hope not. I don't think they do, actually. Yeah. I don't think they have to be strings. But you have a... I guess we would make it strings. So then... So then when you refer to an item in a dictionary, you say... let me think. Okay, well... Okay, so you refer to it by the name rather than by the index. So then we could have a list of dictionaries where the dictionaries have all of the values for them. Okay, so then it would be this I, and I guess we can call it open. Yeah, and then it would be this. Nope. There, and then we change this to close, high, and low. And so it gets these 4 values from the list of candles. Okay. And that would be it. That'd be all for collecting the inputs. Yeah. That'd be all for collecting the inputs. Then, what? What else? We have... What else? I mean, yeah, what else did we put down here? I guess we can change this to be list of dictionaries. Hehehe. Previous candles. Weighted sums, previous layer. That requires, right, because those are going to be lists of weights. Okay, we need functions to generate the starting ones, but then copying them. I guess we can figure that out. For now, we'll do the functions that generate the information. So this would be definition, generate nodes, self, and then how many? I guess, yeah, we want number, or a count, better. There you go. Generate nodes count. So then it would be for self, or for I in self dot... No, I in range 0 to count self dot nodes dot append, and then you have a list, and then inside of that list you you would need to generate a bunch of random, a lot of random numbers between -1 and 1. How would I go about doing that? Like, I can do random float, which technically what I could do... No, because that'd be the same thing. There'd be no difference, because I was thinking, like, I could have it be random integer and then go from, like, -100 to +100 and then just divide the final thing by 10, but that doesn't work. That doesn't help anything, because if I end up with a float, then I end up with a float. So, self.nodes.append what? That adds a singular node. Inside of that, what do I need to put? I need to put... Can I put inside of this a function? Like, what if I did self dot if we do definition gen weights. That's not how you spell that. Weights. Self. And I guess we'll call it count again. I think I can just do that. Because I'm not. Yes, and then you do for I in range. But yeah, for I in range 0 to count, I want you to, when I return a value, does that stop it? Return, or I guess we can have it create a list just called self.weights is an empty list, and then inside of this, for that self.weights append with a rand. Right, I probably need to add math to this, so let's do that. Import math. There you go. Okay. And from this, does math have rand? No. I also need to import random. Or if I import random as rand, that means I can do rand dot, or maybe not. I don't stinking remember. Or maybe from random import rand. Okay, I want rand it, or rand int and rand. I don't know. Does random give me a random float? Let's find out. If we say random, yes, it does give me a float. And I assume this is a range. So if I set that to -1 to +1, just to, as a test, we can have you print random -1 to 1. That'll give me a random float between -1 and 1. Yeah, I probably need to solve that first. Self dot gen weights, and then you. Does that mean you work, or do I need to do what? Oh yeah, get out of here. Boom. Random. Okay, hey. Takes no arguments to given. Well, what the heck? Is that what rand range is? Rand range. You don't explain what any of these do, so I don't know. Rand range. Start integer. Stop integer. Step. Okay. But it says integer. I don't want... I guess in that case, I'm gonna have to do what I was thinking of before. Well, first of all, what if we give it no step? What do you do? -1, -1, -1, -1, -1, -1. Brother, what the heck? Choose a random from range stop or range stop start step. What? My homie and slice. Okay, there you go. It is actually giving other values. That was just insane luck, I guess. Either way. So that means if we set this to, say, 100, -100, 100 with steps of 1, then you will give me random values between these. And if I divide you by 100, then you will give me random floats. Yes. Okay, cool. So then what we're gonna take U and put U here. Boom. And then what am I thinking? Actually, no, it had to be an integer. So that does that. Then finally we oh, I guess we didn't need to I mean, you don't use I. Do we need to? Can I just say for range? No. I guess we can just do that, and then that'll probably be fine. If we return... No, sir! Return self.weights. Then that should mean that you, to generate nodes, will generate a list of weights and add that to the list of nodes, because that should be it. I guess, actually, in terms of... Also, I don't give you a count. I guess we should... Well, no, I'll let that give a count, but for now, for this, I will just do length of inputs, or self.input. There you go. So then, that'll create a list of nodes with... Yeah, list of nodes that are list of weights that all relate to all inputs. Yes, cool. Then, what else do we need? The outputs, which, actually, no. We want weight sum, because that's all that you have to do. The only thing is, with weight sum, you have the inner layer and the output layer that are both doing it. The inner layer is getting a weight sum of all the inputs, and the output layer is getting a weight sum of all the inner layer stuff. So... I guess we can just have that be different functions, I think. Def weight sum. I feel so cool right now. Weight sum inner is probably a better way to call that, but it's fine. Self and node. That way, yeah, because you have to know which thing you're working with. So that will be for I in length, or for I in range, 0 to the length of, I guess, inputs, or no, for I, length of self dot nodes, node. Yeah. Good job, brain. We're doing things. That's not what I was meant to do. Please, press the right button. Okay. For I in range, 0 to length of self.nodes. What else? What do I do? What am I thinking? Oh yeah, I have to get the value right. I guess that kind of implies, in terms of connections, the weird thing is that connections have, unless we have nodes tell you what input they're taking from, and then also the value of the weight, which I guess we would have to do that if we want connections to be affected by mutation other than changing their value. So I guess I will do that. So generating nodes dot append that you generate a list of weights. That doesn't even, okay, wait, so then that would mean in creating the list of weights, it's fine, okay, fine. Generate weight, self.weights is an empty list. You append it with this. Can I do this and then append it with a dictionary, mayhaps? It's not telling me no, which makes me think yes. So then if we have you be, if we say input is I, and value, or value is range, or is that, then that, I think, works. So that means we're appending it with a dictionary that has a value input and a value range. So that tells you what input it relates to and what the value is. Yes. Cool. That means when we go here, that gives me the node. Node. That's the list of that. Cool. Then we want to... So the node itself is a list of dictionaries as well, with the ID in the thing, which means we need to get... I guess it would just be self.sum equals, or no, plus equals. I feel like there's probably a way to do local variables in that. I will figure it out. But for now, we will allow this to be probably inefficient or something. I don't know. So self.sum plus equals self.inputs I guess self.nodes node dot input, or no, not dot input, it'd be in parentheses or in thing input, like that. Yes, I think so. Then okay, yeah, but then multiply that by self dot, I guess it's just going to be this, but instead of input, it's value. Which, should I change value to weight? Yes. Weight. Like that. There you go. So it multiplies that and adds it to that. Cool. Then, that also, this being a list of weights means that I can, before this list, just add a number, which, hold on. You go from 0 to that, which means I can change you to go from 1 to that to skip the bias. Yep, that's cool. Okay. So you're not an issue. I can do self.weight, nope, self.weights dot append with a bias. I don't know how high a bias can go. Let's look it up. Range of bias in neural network. Neural network. Boom. Around Well, the range isn't around 0. This is... okay, whatever. Bias, give me the range, the value. What is the value? You make me upset. Okay, looks like it's... I choose, I decide. So I say it will be between 0.5 and negative 0.5. Yeah. So, append, rand range, I guess, what? 100, or negative 100 to 100 steps of 1, and then divided by 2, I think. I think that's how that works, right? Negative 100 to 100, and then divided by 2. So if you get a... actually, no, divided by 200. Yes, yes, yes. Because then if you get 100, then you get 0.5. And so everything else is going to fall somewhere between that. Cool, good enough. Now, what am I thinking? That is that. That's the bias. Can I add a note to this? I can. Bias. So, you do all of that. And then at the end of that, wait. So, nodes is a list... nodes is a list of nodes. The nodes are a list of dictionaries, which means I do need to, between this, put I. Yes, cool. Okay, and then what? I guess self dot sum plus equals this. No, not this. This. And change I to 0, because that adds the bias. Adds nodes bias. This will multiply and add nodes, or I guess each connection? I don't know. Okay, so that does that. You have the weight sum inner. We need to do the same thing, but for the output. So if we do this, but this, change inner to output. That's not how you spell that. Output. Out, brother. Output. Okay, self. I could keep it as node, given that the individual things are called nodes. Yeah, sure, dude. And that makes all of this the same, except I need to... Outputs... is outputs going to be the same as the nodes? Outputs... because they have their own weights and biases, which means... so output nodes are identical to inner nodes. Which means that I guess I do want to do that. I need a list of the outputs. Yeah, sure. List of output nodes. Nodes are list of weights. I just call that outputs. Like that. So then if we go back down to here, we can change all of these to be outputs. But not all of them. Oh, actually, yes, all of them. Cool. And then I guess we format that in the same way. I think. Is this all good? Like, this is all perfectly fine? I'm gonna put a space between those because it being so squished is hurting my brain. Okay. You add you do the thing outputs node 0, so that means first item should be the bias and the rest is that. Yes. Okay, cool. That means that we can do generate outputs. So that means we actually need to change gen weights to gen weights inner, or if anything, gen inner weights. Yes. No. Well, yeah. Gen inner weights. Not to be confused with inner weights. I don't know what that would mean, but boom. Okay. So gen output weights. Weights. When is this used? Gen inner weights? You set, yeah, then you return output weights. Which one, where's the thing that uses that? Generating the inner weights. You generate nodes. Ah, this. I didn't realize because it wasn't highlighted anymore. Gen inner weights. Hi. Okay, cool. Now if we go back down to gen output weights, we can use weights as well because it's just a little guy. You do that for the bias, then you do that. So that's all. Gen output weights is perfectly fine. In that case, we can kind of just have you be the same. We don't need to do a thing for gen weights. Actually, we do, because you... Yeah, you. You for range and count... Oh, wait, never mind then. I'm perfectly fine. We're actually fine. You will just be gen weights. Yes, okay, cool. Next. So that's gen weights, so that means what we want to do instead of gen nodes is gen outputs. Boom, gen outputs. Outputs for range to count. Then instead of self.inputs, it'd be self.nodes. Huh. Wait. Oh, and this would be self.outputs instead of nodes. So wait, this adds, you generate nodes. You generate, so by generating outputs, I have it run gen weights for the length of self.nodes. Yeah, because I want one for each node. Then, okay. When you generate weights, you do the input and the weight. Should I change? I can change. I can keep it as input. Yeah, I'll keep it as input. It's fine. So now we have it. Able to generate the values for the outputs. So let's shrink all of these so I can see them laid out. Shrink all my definitions, and we can see what all we've done. You have the initial. You have the input. Input does, yeah, that collects all the inputs from the list, or from the simulation. Then you have it generate nodes, generate outputs, generate weights, weighed sum for the inner and outer, or in output. What else is there? Let's see, we still got an hour. List of dictionaries with previous candles. I will put a slash at the end of these if they're done. So, list of dictionaries with previous candles. Yes. Function that... sorry, function that weighted sums previous layer. That's done. For loop that does some function for each node. Weighted sum, you do it for a single node, for node. Yes. So we do need to do that, I guess. So then, I guess we can do that next. Actually, no. Let's make sure of all that we've done other than that. So we need that function that copies information of top performers, that modifies brains of new agents, that processes and produces outputs of agents, that converts currencies. Yeah. Okay. Well, for one, convert, we can do okay, yeah, no, I didn't want that. I want this. Def convert electron to positron, self. I think, well, hold on. Do we do that? In the event, so that, let's say it does that, then you hit that. So it sets the stop, or it sets the marker to buy. Then, or no, will it just be a buy sell? Because what did I say? It says place sell buy. So yeah, the place. Yes. Dang, that means I do need another. Actually, no. No. Okay. So in that case, if we have it just be an immediate thing, like just a market order, then it needs to. What should the exchange be? It can't. Exchanging it. It's just going to be multiplying the exchange percent by the. Yeah, it's just going to be multiplying the exchange percent of the thing. Okay, hold on. Go, show me my input. No, show me this. The exchange amount is going to be multiplying this by which one to... Hold on. Do I need any value for... Oh, it's sell by. Okay, yeah. You multiply that by the value of electrons or positrons based on the value of the sell by, or the SB variable. And then multiply that by the exchange rate, which is also based on that. I mean, I guess for the sake of making it easier, I can do it, but I don't know if I'm going to need it. So, it'd be self.exchange equals, for now, we just do exchange percent, or self.exchange percent. Should the exchange percent... Yes. The exchange percent is going to be a value between 0 and 1. So we can just multiply that. This is assuming it's electrons to protons. So I can multiply that by self.electrons. And then multiply that again by self.ETP, which is electrons to... It's literally just doing that. That doesn't... I don't think I need to make a function for that. I don't think I need to do that, man. I'm not going to, because I don't think I need a function for that. It's just multiplying three numbers. Let's see. We can do simulated market. Okay, so generate candles. We'll have it generate candle, which. Okay, this is going to be a different one. Generate candle. Or no, gen candle. Gen candle. Nope. Okay. Self and I think we just need self for this one. Okay. So oh no. We need the traders. The number of traders. Because that determines the activity of it. What am I thinking? Right. So, what we need to do is set... Generating a candle means that we're going to be adding a list to the list of candles. So, self dot candles dot append, and this is a list of dictionaries, correct? Yes, because it has the open close blah 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 blah. So you append it with a dictionary containing, and then oh no. That means we need to do What am I thinking? I guess we can do self dot, we'll call it CO for candle open equals self dot candles what's the thing for the last item in it? I guess we'll just do length of candles, of self.candles. Does that work? I don't know if it works because it might be last item in a list in Python. Boop. Let's see. Negative indexing? Does that actually work? All of the pictures are saying this works. I mean, okay, sure. So, in that case, it'd be -1. And that'll give me the last item. So, yeah, self.open is the last item open. And then that means that we then need to do... Okay, so then that means we need self.c list, or list. There we go. Because we need to know the highest and lowest value, which means... Yeah. Sorry, we need to know the highest and lowest value, which means we need to keep track of it until all the things are generated. We also need, so that means inside of the candle we need to do the number of, I don't know what you would call it, number of moments? There should be, I feel like there's a word for just like a single amount of time. I guess we call it a moment. Sure, dude. Moments. So, or steps is what I'm thinking of. Steps. So this we add 0, or yeah, set the C list to 0. Self dot C list dot append with, or append with self dot co. Then for I in range, come on, 0 to steps, come on, steps. Then for J, or A, B, C, D, E, F, G, H, I, J, yeah. For J in range 0 to traders, here we go, yeah, 0 to traders, then self dot C value equals, or I guess plus equals, rand, what? Rand, rand int -1 0, or -1 to +1. Okay. That means, yes, that'll add values 0 to 1 for the number of traders, and then it'll do that for the number of steps, but after it does that, I need you to self.clist.append with self.value. There you go. No, not self.cValue. There you go. Okay. So that'll generate random number, or it'll generate a sum of random numbers, that is the number of traders, and then add that to the list. So then once it does that, we need to find the highest one. So self.clist dot you can try sort, because we care about the last value and the highest value. So we can do self.cc for C close equals self.clist, or actually the easiest thing to do here would be no. This is correct. Okay. What am I thinking? Yeah, self.cc is self.clist -1, so the last item in self.clist. Then what? Self.cc, self.clist. So that sets the close value. Now we need the high and low. So let's try I'm not sure if I'm gonna remember how to do this, but self.clist.sort. Let's see. Sort the list in ascending order and return none. The sort is in place. Okay, sure, let's just do sort, and then, well, actually, do I need to put anything in there, or can I just say, you say key, reverse, key, none is none, reverse, yeah, I think it's fine to just leave that. So then, that means we can do self.ch, which is C high, equals, what am I thinking? Or yeah, candle high is self.clist or self.clist -1, so the last item in the sorted C list, and the low, which I'm just stop being a stinko. C low is 0, the first item. So with all of that, we can then say that Open. Where did I set that? Where did I do that before? Inputs? Yes. It's open, close, high, low. Order doesn't actually matter. But open is self.co, comma, and then get out of my way, stinko. Boom, boom, boom. So that would be CO, CC, CH, and CL for open, close, high, and low. Okay, I think that's it. Yes. Cool. So that'll generate a candle. And it builds on itself because it starts at the closing value of it starts at the closing value of the last one. I need to change this from open to close. There you go. Starts at the closing value of the last one, then does more steps, and then it generates the candle. That's cool. Cool. Then I guess we can do, I don't know, I guess self dot sim. What would be the word? Prepare? Setup? Setup. Sure, dude. Setup. And then that means I can do everything that I need to do before the sim. And this is going to be a personal, this is a personal, not self dot, sorry. Def. Sim setup. Sim setup is not accessible. What did I do different? That's why. You're inside of this guy. There you go. Sim setup. Okay. Sorry, give me a second. Okay. Back to this. Yes. Sim setup. So that means we need to, we'll say candles. Alright, we need self. We need candles. So, yeah. That tells us how many candles we want to do. So that means that for I in range 0 to candle, or candles, there you go, we want to do what? For I in range 0 to candles, we want to do self dot candles dot append with self dot gin candle. Right, and then we need to do traders. Yeah. Traders and what? Steps. Sure, because that'll just be the number of steps. So then traders, candles. No, not candles, steps. Okay. Is that everything you need? Yes. So that will generate candles however many times we say. Okay. Then what? Oh, do we need to... Wait. So that means, yeah, we don't need to append it. We just want to do that. Okay. So then you generate candles. Then I guess that's all for now. What else would you need to do? Actually, that is kind of it. You would set... I mean, yeah, if anything, it would be set a starting value, which... Whoa, sorry, I thought I was falling. Okay. Do I need to shrink this back? Did you change in size? No, you did. I forgot I did that. So move that there, I think. A little more. Wrong thing. There you go. Okay. Come on, smidge more. There we go. That's just me resizing chat for NOBS. Okay. We need to set a starting value. Should it always start at 0? Or should the starting value be 0? Or random? I think it should be random, because that represents coming in at different times, I guess? Right? Like, the starting value... Yeah. So then that means we want to do... I believe... We go here. You have electron, botacons, block conversion rates. Having them be different exchange rates might be easier for, like, quick math or whatever. But they are the same value. It's, Yeah. It's like, it's just a ratio, and then one is the reciprocal of the other. So, okay. But what am I thinking? I'm thinking you set the... Right, it's basically the open value. So then should I have it manually create a... No, I don't want it to manually create a candle. It's... Can I create an optional thing? I guess... Yeah, we'll do offset. We'll create offset. This only applies to... Yeah, plus offset. There you go. So that's the previous thing, plus offset. That should... This. I'm worried about this. This doesn't exist. In the first candle, this won't exist. I assume this will exist because the list exists, so the last item in it is just going to be there is nothing. You know what I mean? It'll be 0, effectively. This, having closed, though, of that, is like that list that you're looking into, or the dictionary you're looking into to find the value of closed doesn't exist, and I'm worried that that'll cause issues. So... What am I thinking? If we have self-dot candles, I guess we can just put an if around that. I don't know if I would be... I don't know that I need to do that, but I guess it's better to be safe than sorry. So, if... What? If... I guess just... It'd be this. If that. Can I just do that? I can. And then an else. Then you just set it to offset. Although I guess if I'm gonna do that, then that means that I can kind of get rid of this. I guess no. No, I won't. I'll leave that. Okay, cool. So with that, then we can generate, so then candles -1. That way I can have manually do this with an offset of a random, I guess, integer between what? -50 and 50. There you go. So, and I will mark this so I know why I did this. It's starts sim at random value to represent coming in at different times. Cool. And that's all we have for sim setup. We have 20 minutes left. Can I do anything else? Function that... Okay, let's see. I guess I can do the one that converts them. I'll put a big X next to you. Simulated market to each agent. That generates market movements. That is done. That's generating the candles. And this is also done. These are all done. So what here have we not done? You process the outputs. There you go. Processing the outputs, no, because you can't do any of the things yet. Modifies the brains of new agents, and copies information of top agents, and loops the sum function. I have a sum thing, right? Yeah. Yep, we have a function that does the weighted sum, but we don't have a function that loops it. That's fine, because I want to... Okay. I do want to add to this visual... I guess, sure. Visual, I guess, indicator of top performer. That way, it's less boring. Because technically, all of this can just run purely virtually. But I think it'd be cooler to be able to see the stuff. And so, yeah. So, I want to be able to see stops or see orders. Do you see the orders? Do I want to see the orders? Because you can only, it's like an immediate thing, so I guess, yeah, see orders. I want to be able to obviously see market, or see candles, I guess. Candles. Then what? See orders, see candles. See... I don't know. Oh yeah. I want to be able to see currencies. There you go. And then I may as well also see sim info, like the generation. I guess that's kind of it. You have the generation. That's all the sim info. That is like the candles. Well, even that's not. The agents themselves are the only things that are continuous through the simulation. Everything else is different for each one. So I want to see the candles, currencies, and I guess and score, which would just be value of. Would it be the highest value of all your stuff, or the value of all your stuff in a single currency? Because I'm thinking, like, if you have 200 in electrons, 700 in positrons, and you're just waiting for the exchange rate to drop enough for you to convert however many of your positrons back into electrons to make a profit, then, you know, but I guess that's still, I guess having it be, value of currency and electrons. Currencies and electrons. Yeah. Okay. Yeah. So that's that. That would be a different thing, although... I don't know what to do in terms of... Okay, because this, right? This all depends. We want to see the info of the top performer, which means the one with the highest score, or like, highest score, which is this one. And I am trying to think of how you would do that in terms of you have to determine which one has the highest score presently, and then which one, which one has the highest score, and which one, brain. No, that's correct. And where that is in the list, or the info of it. So to determine which one has the highest score, you have to compare it to all of the other agents. I think the easiest way to do that would probably be like to have a list of all of them with their scores. But can you sort a list by a... Like, if you have a list of dictionaries, right, then I can have each one be an item with, like, one ID, like an ID and a score, right? So then I can sort it by the score, and then the highest item... Wait, is that ascending? Generate candle. You. When I sort you, you are ascending. So the first item is the lowest. Okay, yeah. Sorry. So, yeah. If I... Can I sort a list? Like, if I have... If I list... equals this. Can I do list? I guess list dot sort. It says key. Is it possible that's what that's referring to? If I add artificially some values into here, we can just say like ID, which one? You. ID is A1, or like a string A1, and score is... Nope, come on. Score is what? We'll just say 100, right? And then add another one to this list. We'll add two more. One with a score of 70 and 50. 70, or no, we want to make sure 50, 70. So right now it's out of order. So when you give me key equals what? Score? And then if I print list, will that be in order of key equals score? Yeah. What string is not string object is not callable? What does this mean? What, key 1 or something is not callable? I don't know what you want from me. Key equals. Do you clarify what a key is in this? Key. Dictionary, string, any. So I think I need to say, huh? The key, if a key function is given, apply it once to each item and sort them, ascending or descending according to their function values. What? What? I do not understand. Okay, if we say key equals parentheses. Okay. Dictionary. I guess dict. I have no clue. Yeah. This. I don't know. Do I, in parentheses, score? Like that? What? What are you expecting from me? Is not defined. Score any. I don't know. Bro. Meh. Okay. String any. I genuinely don't. Okay. I'm going to use Google again. How to sort list of dictionaries Python. Key. Yes, okay, but tell me how to do that. This is, no, Stinko. Wow, you're very annoying. And that gives you, that sorts the items in that. I don't, it's, what the heck? Okay, no, I want a list of dictionaries. This. Okay, okay, okay. Ow. Okay. What am I thinking? Sorted? The sorted function takes a, okay. So, sorted. List to be sorted. So this would be sorted list key lambda goes lambda. There you go. And then D, which I think can be anything. I like X. I want X. Stop it. Stop being a stinko. X is X. Okay, here we go. What am I thinking? Score? Like that? What is wrong with this? Oh, that's why. You don't do anything. Like that, and then that would sort it. Okay, and then you have a new list. I guess new list equals this, and that would give me the list sorted by the item in the thingamajig. That gave 50/40. Yep. Cool. Reverse. True. Fall. What do you want? Reverse equals true. Yes, capital true. Now if I do it. Okay. Obviously I don't need that. That's not necessary. I can just look for the last item, but... So, given that, and then I... Okay, yeah. So... Why did I want to do that? Right, that was for the agents. I needed to be able to tell who the top performer was by their score. Oh, you should be A2, by the way. A2, A3. So, in that... So, I need a bubble ball. Yeah, that lets me sort them by their score. And that's pretty simple. Since I can sort them by their score, that means I can find out who is doing the best and give the info based on that. Okay. So... Alright, well, we only have 4 minutes left in stream, so I won't be doing that, but we know what to do next time. I guess next time, we'll get it working, I don't know if theoretically is the right word, but we'll get it working virtually, and then if we have time, we can start working on the visual representation of everything that lets us have some kind of entertainment in watching this go. Then what? Then what do I want to do? Once we have that, the thing about that is time. I guess what we can do is, once we have it working, the stream after that will simply be watching this go. Yeah, that'll be, the stream after that will just be watching this thing go. So it'll just be 4 hours of that. And then we can come back at the end and see how well the final guy is. Although, I do worry about how to save that. I want to be able to stop it and get the info of the best guy. So, I'll figure that out. So then that means that here, I'm gonna put a note. Find out how to get the info of the last, or how to get the, we'll say brain of the last agent, so we can see how well the AI did in the end. So yeah. Don't know how long. Honestly, we got a lot done today. So, yeah, we got a lot done today. So I don't know how long it will take for. And I can get rid of this. Get out of here. Yes. I don't know how long it'll take to get this working. Period. I guess just in a sentence. I don't know how long it'll take to finish this, and then have that stream where we just have it go for 4 hours. I I don't know, man. I forgot what I was gonna say. I don't know. Well, there's 1 minute left in the stream, so I'm just gonna control S. And if you would be so kind as to join me back where it all began. Today was a good stream. Very fun. My mouth is very dry. Well, I mean, I guess it doesn't feel like I talk more than I usually do when I'm on stream, because I talk to myself all the time as if I'm being recorded 24/7. So it's like, I don't feel like I am, but maybe I do. I guess, yeah, because I'm more okay with being quiet for prolonged amounts of time when I'm just by myself. But obviously, when I'm actually being recorded, then I have to talk more because, you know, there's people that require entertainment. So, but today was a good stream. It is now 6 o'clock, so I must bid you adieu. But this is a good song to end off of, my favorite song in Minecraft. Goodbye, have a great day, and see you Tuesday.